We'll now look at the mean and variance for these probability distributions. And we'll start with the mean. The mean is actually given by adding up the product of your random variable times its probability. So we multiply all of our probabilities by their random variable and then add them up. For variance, we add up x squared p of x. So this time we need to square x and then multiply it by the probability. And once we've added all of those up, we subtract the mean squared. And then standard deviation is always the square root of variance. So we'll do a couple of examples of using these. Here's our probability distribution for rolling a standard die. We want to find the mean and the variance in the standard deviation. One of the easiest ways to do this is to continue your table down. We're going to start with adding a row for x, p of x, where we just multiply the two existing rows. 1 times 1 over 6 is 1 over 6. This gives me 2 over 6, 3 over 6, 4 over 6, 5 over 6, and then finally 6 over 6. I'm also going to add one more row for x squared p of x. This time I have 1 times 1 over 6, 4 times 1 over 6, 9 times 1 over 6, 16 times 1 over 6, 25 times 1 over 6, and then 36 times 1 over 6. To find our mean, we just want to add this third row. 1 over 6 plus 2 over 6 plus 3 plus 4 plus 5 plus 6 over 6. And when we work that out, we get that our mean is 3.5. To find our standard deviation, we start by adding the last row. 1 plus 4 plus 9 plus 16 plus 25 plus 36, all over 6, to give us 15.17. And then we need to subtract out the mean squared, so minus 3.5 squared. This gives us a variance of approximately 2.92. Our standard deviation is then the square root of that number, approximately 1.71. Let's also suppose we have this one, and this will just be something random. Maybe we're playing a game that has these different options and these probabilities. Once again, we want a row for x p of x. Here I have 4 over 8, 2 times 2 over 8, 3 times 1 over 8, and then 4 times 1 over 8. One more row for x squared p of x. This time I have 1 times 4 over 8, 4 times 2 over 8, 9 times 1 over 8, and 16 times 1 over 8. My mean then comes from adding that third row. 4 plus 4 plus 3 plus 4, all over 8, gives us that our mean is 1.875. Standard deviation then comes from starting by adding the last row, 4 plus 8 plus 9 plus 16, all over 8, which is 4.65, and then we subtract the mean squared. And when we do, this gives us 1.11. Standard deviation is then the square root of that number, which then gives us approximately 1.05. The last thing we'll look at here is expected value, which we denote by E of x. And this is the same thing as the mean. It's just different notation and a different word. Essentially, usually when we're playing games or anything involving money, we like to use expected value rather than mean, but ultimately they are the exact same thing. Let's suppose we are in a raffle that's selling tickets for $2. And we know that we have 300 tickets that have been sold. The prize is worth $300. Well, we're going to suppose we bought 1 and figure out what the expected value is. We need to start by building a probability distribution. In this case, we have 2 options. We can lose, in which case we spent $2 and lost, or we could win, in which case we win $300. But we still did have to spend $200, so in reality, we only gain $298. We have a $299 out of 300 chance to lose, and then a 1 out of 300 chance to win. For the mean, we then multiply these 2 numbers. Negative 2 times 299 would give us negative 598 over 300. And on the right, I have 298 over 300. Then we can add these 2 numbers up, and we get a total of negative 1. Essentially, we should expect to lose this game. That's what the negative number means. The fact that it's 1 tells us that if we do this exact same raffle many times, overall, we should expect to lose about $1.